In this question, we're going to calculate the relative molecular mass of a volatile liquid using the equation of state for an ideal gas. Okay, so the equation of state of an ideal gas is PV equals nRT. Alright, so in this question from the Chemistry Live textbook, 2nd edition, page 138, question 10.12, we're given the following information. So we're told that we're looking at chloroform. We're given the mass of chloroform is 0.495 grams. We're told that the volume is 127 centimetre cubed. The temperature is 98 degrees Celsius. And the pressure is 100.5 kilopascals. Now, I've just also written in that the gas constant is 8.31. So this number, this value will be given to you on the front of your exam paper. Okay, so in order to use PV equals nRT, to find the relative molecular mass, okay, we have to write the quantities, the volume, the temperature and pressure in the correct units that are suitable for this equation. So the mass is fine, we're going to use that later. Volume needs to be in meters cubed, okay, not centimeters cubed. There is 1 million centimetre cubed in a metre cubed. So in order to convert centimetre cubed into metres cubed, I need to divide this value by 1 million, which is 1 by 10 to the minus 6. So we end up with a volume of 127 by 10 to the minus 6, okay? Now, the temperature must be in Kelvin. So to convert degrees Celsius to Kelvin, I need to add 273. So if I do that, I get 371 degrees Kelvin. Pressure needs to be in pascals, not kilopascals. 1 kilopascal is 1,000 pascals. So let's multiply this number by 1,000. And that'll give us 100,500 pascals. Okay, so we have all of our quantities in the right kind of the right versions of them. So now what we're going to do is we're going to use our equation PV equals nRT, and we're going to use it to find n, the number of moles. Okay, so we want to find the number of moles of chloroform, okay, that would have this pressure, this volume, this temperature. Okay, so the first thing we're going to do is we're going to rearrange our equation, our ideal gas equation. So N is going to be PV divided by RT, and then we're going to literally do our calculation, okay? So to find N, it's going to be P for pressure. So the pressure we have up here, okay, we have it all written out already, 127 by 10 to the minus 6, multiplied by the volume. And the volume, sorry, that was the volume, okay? So the volume was 127 by 10 to the minus 6 by the pressure, which was 100,500. We're going to divide this by the gas constant, or which is 8.31, times the temperature in Kelvin, which is 371. Okay, so when we work that all out, we end up with, so you use your calculator, you calculate that, you're going to end up with 4.1399 by 10 to the minus 3, or you might like to write that out as 0.004139. Okay, so this is the number of moles of the chloroform that we have, okay? Right, okay, so we're nearly there. So the aim of the game is to work out the relative molecular mass, okay? We now know the number of moles, okay? And we have our good night, Mr. Tom triangle, good night, Mr. Tom triangle, to relate grams, mass in grams, number of moles and relative molecular mass. So we know from earlier on in the question that the mass given is 0.495 grams. So let's just rearrange, or well, let's figure out the relative molecular mass. So using our good night Mr. Tom triangle, we cover over relative molecular mass, and that's equal to grams divided by number of moles. Our grams given in the question were 0.495. Divide that by the number of moles, which we just worked out from our equation. Okay, you can write it in either version, okay, and that is going to give us, when we work that out, that's going to give us a value of 119.568. Okay, so that's going to be your relative molecular mass for for chloroform. That's my final answer. Let's just highlight the final answer here.